So it's interesting, the different vendors have very different approaches for acquiring multi-energy data. And so when comparing them, one important consideration is how much separation is there between the spectral measurements, or in other words, how unique are they? Another important consideration is what is the time between the spectral measurements? For example, with dual energy, what's the time between the low and high spectral measurements? Another important consideration is how much control do you have to adjust the dose allocation between the multi-energy spectra? Ideally, you would want them to be pretty equal between the low and high measurements. And another consideration is just workflow in terms of acquiring the data and also reviewing the images. What sorts of tools are available? Well, in terms of spectral separation, the more separated or the more unique the spectra are, the more dose efficient your system is when you're trying to do material decomposition. So that means the less overlap that you have between the spectra, or in other words, the more unique they are, the better trade-off you'll have between image noise in your material decomposed images and the dose. In terms of the time between spectral measurements, if you're able to acquire for example, high and low measurements simultaneously, or very close to simultaneously, you can perform what's known as projection domain processing, which allows you to remove beam hardening artifacts. Also, if the measurements are close in time, then you won't have issues of motion artifacts and other dynamic changes. As I mentioned, the different vendors have very different approaches, and it's really hard to compare them. So one system might have very good spectral separation, but the spectral data are not acquired simultaneously. So that system has some advantages, but also some disadvantages. And that's true when we look across all the vendors in the currently implemented spectral CT systems. So it's really hard to say which one is best. However, there is a technology that's under development that has the potential to be definitively the best spectral CT acquisition method, and that's known as photon counting. There are currently prototypes for clinical scanning, but not yet a commercial product. And photon counting detectors have the potential to provide either equivalent spectral separation or hopefully maybe even better than today's spectral CT systems. The spectral data is acquired simultaneously, and they have other image quality benefits, including better dose efficiency and spatial resolution. So hopefully we'll see in the next few years, it will be easy to answer that question to say that photon counting would be the best spectral acquisition, multi-energy acquisition method.